Hello, my name is Alexa, and today I will be presenting on the feasibility of power factor correction implementation. My audience is online due to the current circumstances, and will be sitting right next to the camera's viewpoint. What are the benefits of improving the power factor? The benefits are that the electric bill will get reduced by increasing efficiency, and the indirect carbon emissions will decrease also. By decreasing the current that goes through the wires, power factor correction can increase the equipment and wiring working life. So what is power factor correction? Well, there are two types of loads. One, inductive loads and capacitive loads. Those are both reactive loads. So reactive loads cause imbalances in the supply system. It is as though you're pushing a rock, but instead of pushing with a force parallel to the horizon, you're pushing up on top on it. So you're not using your energy most efficiently. That is what is happening in factories when an excess of inductive loads is present. So to combat the inductive loads, we use capacitors. Another benefit of power factor correction is the reduction of long-term electricity costs. Industrial equipment is inductive in nature, and we have to offset it with capacitance. So a bad power factor decreases efficiency and increases the cost. Here we have a chart that represents some annual savings that can be achieved with power factor correction. And here we see like a $17,000 saving annually. Another benefit of power factor correction is the reduction in indirect carbon emissions. So why do we care about carbon emissions? Well, carbon emissions are bad for the environment, and a lot of places around the world have implemented or are currently implementing carbon taxes, which could also be accounted for in the reduction of electricity costs. So most of the electricity produced in the United States comes from petroleum and natural gas, which are non-renewable sources and therefore produce carbon emissions. We also want to keep a good image of the company, because sometimes you have to publish your annual carbon emissions. Another benefit is the extension of the equipment's working life. By providing a more steady current and a current that the equipment is designed for, we are reducing the amount of current that flows through the equipment, reducing the heat and extending its working life. Another benefit by reducing current is the future-proofing of the existing wiring system. So less current means less stress on the power system and increased efficiency, and less stress on the transformers, meaning that we can add more equipment or upgrade the wiring system later, which is very expensive to implement. So, an example of power factor correction implementation. I featured an example of a telecom factory in India that implemented power factor correction in its telecommunications facility. So power factor correction can be used in a variety of cases, from industrial, which it would be most effective for, to telecommunications, which I implemented an example of in the research paper. So documentation about power factor correction is not readily available to the public because it is for internal uses usually, and the facility is not required to publish the papers. So recommendations. First, check the power factor to see if power factor correction is necessary. Next, determine what kind of power factor correction is necessary, active power factor correction or passive power factor correction. In facilities where the inductive loads are changing, there you will need active power factor correction. If the inductive loads are on or off type, then you will need passive power factor correction. Then determine the amount of equipment that causes harmonic resonances. Now those could be redundant PSU supplies, or they could be servo motors or anything that causes harmonic resonances. If the amount of equipment that causes harmonic resonances is really high, then additional equipment to keep the harmonic resonances low is needed. And do not rely on outside sources for calculating savings, since every facility is different. And to recap, the benefits are reduced electric bill, reduced carbon emissions, lengthening of the power supply, and equipment working life. Any questions? Well, that's it for today.